Welcome recruits to Phase 6, Part 1 of AP Calculus Bootcamp, Operation Accumulation. Your clearance for Level AB is authorized. Today's operation covers topics 6.1 through 6.8, focusing on Riemann approximations, the fundamental theorem of calculus, and definite integrals. Status, mission go. Listen up, because the operational paradigm has shifted. In previous units, our primary intel was the derivative, representing instantaneous rate of change or slope. Now our new intel is the integral, which evaluates the accumulation of change, represented visually as the area under a curve. Remember the unit rule. Calculate your accumulated units by multiplying the unit of the rate by the unit of time. For example, gallons per hour multiplied by hours yields total gallons accumulated. We begin with tactical reconnaissance, manual area approximation. When exact area formulas fail, we approximate using Riemann sums, building rectangles under the curve. A left Riemann sum uses the left endpoint of each subinterval to dictate the rectangle's height. A right Riemann sum uses the right endpoint. You must master the error diagnostic protocols to determine if your approximation is an overestimate or an underestimate. For left-hand sums and right-hand sums, the error relies entirely on whether the function is increasing or decreasing. However, be on high alert for the trapezoidal error override. A trapezoidal sums error is dictated purely by concavity, not direction. A concave up curve yields an overestimate, and a concave down curve yields an underestimate. Next is signal decryption. You must know how to translate a Riemann limit. When the number of subintervals approaches infinity, the limit of an infinite summation mathematically transforms into the exact area calculation of a definite integral. A successful agent can seamlessly break down this complex limit expression into its familiar integral components. Prepare to deploy the ultimate weapon, the fundamental theorem of calculus, Part 1. We define an accumulation function, g of x, which tracks total area under a rate function f of t from a fixed start point A to a moving endpoint x. The FTC provides a tactical short circuit. Taking the derivative of an accumulation function simply unlocks the inside rate function, evaluated at the upper bound. This allows us to execute behavioral mapping between the rate function f of t and the accumulation function g of x. Because g' of x equals f of x, the rate graph f acts exactly like the first derivative of the accumulation graph g. All your previous analytical tracking rules apply. For instance, when f of t hits 0, g of x has a relative extremum. To manipulate the operational zone, memorize these definite integral field modifiers. Reversing the feed. If you flip the limits of integration, you must reverse the sign to a negative. Splitting the zone. You can break a continuous integral into adjacent intervals, adding them together. Scaling the signal. Constant multipliers can be factored outside the integral. When you need exact area, initiate the execution protocol for FTC Part 2. This bypasses infinite Riemann limits. Step 1. Define your target definite integral. Step 2. Acquire the antiderivative, big F of x. Step 3. Set your boundary evaluation bar. Step 4. Final execution. Substitute your upper bound into the antiderivative and subtract the lower bound evaluation, big F of b minus big F of a. Know your base loadout, the antiderivative arsenal. You have two weapons. Definite integrals yield an exact numerical area. Indefinite integrals yield a family of mathematical functions. This brings us to Protocol plus C. Never deploy an indefinite integral without the constant of integration, plus C. Doing so instantly compromises the mission. Strict rules of engagement apply for exam notation and justification. Directive 1. Never drop the missing differential. dx or dt is structurally required. Directive 2. Calculator setup protocols dictate you must explicitly write the full definite integral on the page before dropping your calculator's final numerical answer. Directive 3. Avoid linkage errors. Do not chain false equal signs while translating limits or simplifying expressions. Time for the after-action report. Let's debrief Phase 6, Part 1. 1. Accumulation is found by integrating a rate function. 2. The infinite limit of a Riemann sum mathematically equals the definite integral. 3. By FTC Part 1, the derivative of an accumulation function simply reveals the inside rate function. 4. By FTC Part 2, exact area is evaluated analytically by finding the antiderivative and calculating big F of b minus big F of a. End of Phase 6, Part 1. Prepare for advanced integration techniques. Status: dismissed. For more AP Calculus Worked Out free response question solutions, like and subscribe to get your FRQ on.